safe. Use all the safety precautions and equipment when doing labs, or else you end up like this guy. The things you'll need in this lab are 1. Slinky, 2. Stopwatch, a meter stick, and 3 or more people to help you with the lab. Now before creating the standing wave, you need to know the wavelength. Now the wavelength in this case, in this lab, was to have 5 meters. As shown in the blue arrow, we measured 5 meters and used that as a wavelength. The slinky you see above is held by 2 people, pointed by the arrows that are blue color. When making the harmonics with the standing wave, make sure only one person creates the pulse. Otherwise, no standing wave will be created and it will just be a big mix-up, and don't measure those data. The stopwatch comes real in handy for this one. You have to measure the time for the standing wave to reach this point to this point and back to the top. After figuring that out, you can use the data that you just figured out to solve for the other variables in the lab. First, we figure out the time that the first harmonic will take, then the second, and the third. Now, we did the fourth one, however, it wasn't visually as pleasing as it was the rest. You can still try doing the fourth one, but it's extremely hard to accomplish.
Triple?
Yeah.
Triple? A triple? Tell me about that.
Yeah.
Oh, she's getting 4? Okay.
One tip for choosing a partner, don't choose someone as weak as him. After getting all your data and writing them down, these equations shown above will be very helpful in finding out all the variables you need for this lab. This lab, only thing you do need is the frequency and the wavelength, and these 2 equations can help you get there. After using these equations, you should have figured out the frequency and the wavelength. Now with both of these, you can graph them and figure out the relationship. The graph on the first try may not look linear, but you can always linearize this graph. For example, you could put 1 over the frequency, or for all the values of the frequency, with the wavelength, and you can find a relationship, and that relationship will be a linear relationship as shown above. We can now officially say that the relationship between the frequency and the wavelength of a standing wave is inversely related. We also know how a standing wave is created. It's created by 2 waves on the opposite sides of the medium at the same frequency.
Well, that's all, folks.